Maybe I'll just sit outside. I have headphones, so it's not a big deal. Literally just make a weird deal of that scared. What do I do? Well, somebody else had already done that.
Yeah, we're in the forefront.
It's very
I had that
personal.
in the other time. This is all very experimental, guys. And being recorded, so smile the whole time. You just turn red in the face like in there. I'm turning your chair around.
Very intimate.
Yeah. Hello. Okay. That's how loud you gotta be. I hope you promise to be loud in 2 minutes. For now, it's church time. Yeah, your prayer.
It likes me.
It's not getting any better, is it? Oh, see, I gotta keep talking.
Yeah.
Yeah.
I make noise, it turns to me.
Well, all that's fun. I'm supposed to be sharing that. So I'm not sure of the point of this.
Yeah, I don't know if your camera's on. I don't know if you can see that. So it said share screen, but I don't think your camera's on.
Just like your profile picture.
Yeah, so I think you might need to share your screen, turn on your camera and have that working. I'm not sure.
Without this?
No, with it.
Okay.
So if you go on your Zoom, I think your camera's off.
Well, makes a lot of sense, but I still don't understand what you're saying. So minimize it.
You go on your Zoom.
Looks to me like a camera is on somewhere.
So now it says start video at the top next to it. So you hit that to get rid of the ads.
Yeah.
Here.
Do you see where it says start video on the top next to the mic?
Oh, yeah. I remember from teaching.
Yeah. I think you select the first one.
Yeah.
So much.
And then just
Click on start video.
Where are you
Yeah,
pointing?
To the right of the mute button.
Right here?
Yeah, just click that.
Yeah,
Gonna unmute it, or it's gonna
It
start.
should.
it should, but it's not.
It's
working.
not though. It looks like it's glitching. Yeah. the camera's-
It's working now.
Hello, is that, who's online?
Josh, it's working.
Thank you. Let's not touch anything. So from here, I should be able to share a screen again, or?
It's sharing right now. It should be.
Yeah, if you just go on your PowerPoint, it should still share.
No.
Josh, can you see the PowerPoint
Yep, everything's good.
popping up? Eh? Okay, thank you. Wow, I got a backup job with IT now. But I'll make sure to have Anneli next to me. And He has a fourth-year thesis on technology, so.
Not really, but sure.
Yeah, well. Close enough for sure. And we're 2 minutes late, as I promised. So because of the mask, because of the proximity, because of COVID, and by the way, breaking news, Ontario is going down in COVID cases. Keep in mind that that's a level we want to achieve at some point collectively. And they announced that the 5 to 12-year-olds can be vaccinated as well. So they're part of the crowd, they're part of the pandemic, obviously. They spread back to their parents, back to their grandparents, and so on, you know. So all we hope for now is I don't know, 5,000 new nurses coming in the hospitals to relieve the ones that don't want to work night shifts anymore, so that the surgeries can go back on. So there is plenty of hospitals who are just dead at night. They should be doing surgery, you know, long surgery, 5, 8 hours sometimes. So 3 nurses in the room. Need a lot of staff to do that. So anyway, looks like the incoming in the hospital system is under control so far. That's what we want to get to, and then hopefully get back on track with the people who are waiting in line for surgery. Breaking news. Yeah. Just warming up the audience. Still adjusting my mask. Sorry for the bad fashion here. You remember the context here. So wildlife management is a 4th-year class. That means I have to assume that much of the stuff that I'm teaching is boring, and that means that everybody's on par on understanding the main parameters, ecological parameters involved with. So you can talk to a lawyer, have a meeting, and say, I represent the ecology side of things. I'm telling you that deer is over about 20 times, and I do the science part. Same way that health organizations rely on science for COVID stuff like that. All right. So I'm throwing the basis for many of you. It's a bit boring. That's only good news. If you leave, it's because you know that material ahead of time. That's great. So let me see if we can be daring enough to go into a wow. There's some good days. So you remember this? I highlighted some that are more important than others because we're dissecting the entire ecology, just to pinpoint the areas where we have an ecological situation. If there's no situation, there's no wildlife management, correct? You're not managing earthworms, nobody is. Because it's wildlife, but it's not in contact with humans, and therefore do not create problems. So commensalism could be an issue. Some animals like us, the fox, the coyotes, the mice in the fields, the raccoons around the cornfield, they all like us. They like what we do, of course. Tens and tens of square kilometers of corn just waiting, because this one tree that has 2 parents and 16 kids. The thing is, and I hope you can pinpoint that at the exam, but in this case, it's positive for the animal, and to the ecologist, it only means that the population is likely to grow in our presence. Am I right about this? Our presence benefits the animal. It's a positive. That means it benefits the fitness of the animal, it benefits the survival. I've seen raccoons live in barns for about 12 years. They were old, like really, but they were totally protected. So their fitness increased. They might have had 4 or 5 litters. So in the definition of a command cell, and that's why the principle itself is very important. It includes a whole bunch of aerial species that come in contact with us because they like us, correct? So right there, I got a condition, a possible condition for management. Yeah. If I see, I don't know, I think all kinds of stories, snowshoe hare comes in my yard, I don't have stuff in my yard. It likes my cedar. It's commensal until there's I'm gonna push it a little bit, let's say 150. Suddenly it's not so much fun, correct? I got too many, overabundant. So that's why it's in the yellow, because there's a possible situation with these animals. The fox on campus is commensal, but it's under control because it regulates itself. There's no stampedes of red fox anywhere. But some animals like to get together a little bit. So one rabbit, suddenly got pushing it 150 or even 20 is a problem on their lawn. Situation in Sudbury right now. Captive release of domestic rabbits that are very happy with the gardens and New Sudbury. They like it a lot. Competition. You can imagine that any animal that takes our resources away. Did I say a limiting factor? Absolutely essential. Animals using a tree, and you want to use the tree, but there's 10,000 trees. You don't have competition. There's no limiting factor. But it does exist. So in other words, you got the hunter who says, I used to walk one day for my moose. Now I have to walk 2 weeks for my moose. Moose is going down. I hear a lot of wolves at night. Well, that's competition because there's a limiting factor. All right. I hope this is clear for everyone. There is no development question at the exam, so it should be pretty straightforward. It's about the ecological concept that matter to wildlife manager. And I haven't seen the end of it. I could work 10 years on this class and still improve on it and refine it. It's quite a discipline for sure. I'm trying to stick to the science, of course, as opposed to political. We're not marching for Greenpeace anytime soon, are we? Unless you really want to, let me know. So parasitism, of course, is very important just because an animal that has parasite loads, I mean, we're going to see that over and over again when we look at specific cases of animals that they're probably become nuisance only because they carry pathogens. You want to write down a fancy word, pathogen, of course, very large term, not very medical, very large, of course. It's anything from bacteria to viruses, microscopic that can kill you. And then predation at the bottom, of course, is important. Predation in itself is an interaction between two species, one attacks the other. It happens that we're midway somewhere, so we're not apex. Well, we turn into an apex predator. Did I say apex predator? Go for here, write this down. That means at the top of the food chain. Apex predator. These animals have a special situation that nobody wants to attack it. When you're a 6-year-old grizzly, I think you're good to go for quite a while, unless there's another there. But for our size, plenty of stuff that can kill us in a flash, correct? Think of Alaskan survival, because they have all kinds of very large mammals, including the brown bear. And so their backyard needs electric fence. You know, you need to protect yourself so you can be afraid. That's why I'm discussing predation. It's bidirectional because you could be the prey, you could be the predator. Of course, we try to be apex so that we're fully protected, protect our kids and so on, and at the same time bring food. Therefore, we are predators. Of course, people these days, they try to hunt at two basics, a little different for environment. You don't need too many weapons, the card, the wheels on the card, of course. And then, but otherwise, if it had, if we, I mean, if I don't know why I stall on movies about both apocalypse, but you have to start from scratch, definitely. Weapons will come handy very, very quickly. All right. So predation, we can't help it. I think if we had to reinvent human, I mean, from scratch, we would have probably to let go of the vegans, let go of the vegetarian, let go of the carnivores, only the carnivores. Basically, everybody will turn omnivore in a hurry. And if you haven't eaten for 3 days and you see something fresh in front of you, I think you will go for it. So same thing for people like meat only and they see blueberries. As the next black hair. He goes for fawns in May, goes for blueberries. The red fox does the same thing. He eats mice the whole winter. And then goes for fruits when raspberries are out. So all day long. All right. Same for flowers. Many bears will eat willow flowers and so on during the season. All right. And when we get into the science of predation itself, because I've been teaching animal behavior in French for the longest time, that's my training. Predation is, it includes even when they publish on chipmunks, they don't laugh yet. They consider the seed as a prey and the animal as a predator because there's the same kind of strategy for finding the. So keep mind open over predation. It's not a simple thing to talk about predation at all. Sorry. So we've seen these already. So this is what's just a warm up because I'm not going to repeat this class forever. So we've talked about these already. Mutualism is no example. That means I will bring hasn't found anything interesting to mention about mutualism. I'm sure there's cases. We'll still set the issue of management with mutualism if there are cases of animals that benefit from the humans that benefit from that animal. I can think of cases, but they're very temporary. For example, if you're growing alfalfa in your garden and you have groundhogs, the groundhogs like the alfalfa. It happens that the alfalfa will resprout twice the speed after being munched on. But any gardeners here? No, excludes any kind of gardener. Okay, but I mean, clipping is common procedure just to increase growth, so resprouting. So that would be mutualistic. You're happy to see groundhog is happy to see your alfalfa, but it's temporary at some point. Too many groundhogs. So that's where I'm getting at. That mutualism is good. It's positive for animal, positive for human to a certain point. So this is going to be the story for this class. Abundance is key. It's just too many of a good thing is not good, right? So too many deer, too many moose, too many wolves, too many anything, too many elephants, name it, too many manatees in Florida, and so on. All right. So we know this already. So we've talked about the individual, we've talked about population, habitat. These are parameters. So bring that in a special little drawer in your mind for the exam. What do we study with population? Density, I think we were about here somewhere. So I think we stopped right at this one. So density is another one. So the topic is about right? So the numbers, simple, right? But it depends how they stick to one another. Some animals tend to spread themselves evenly to the left, uniform. At a very large scale, I would say that think grizzly bear or the combination. They space themselves out. There's no way they're going to overlap their territory, their home ranges. Because it's called territory, that means it's territorial. That means it excludes the others. Conspecific. Did I say the word conspecifics? Yes. Middle is random, and people heard me say that it's a fake. Is just to recognize that sometimes if you throw a bunch of new animals somewhere, they don't distribute themselves appropriately, that means we can't predict their distribution. So put in brackets, I don't have any case of animals who are totally random. Most animals have a strategy, even earthworm, with their conspecifics. Closer, whoop, too close, whoop, back up a little bit. Say this again. The brown bear is solitary and territorial. It sounds like it's not going to make babies anytime soon. Well, the answer is no. It's within the population. All right. So they are seeking each other, but just at the boundaries. Very important. Of course, there's you need at least one male, one female for a population. That's why we still don't have cougars in Ontario, because if you see one cougar, you don't have a population. You're not managing cougar, you're not conserving cougar. It's more than likely a captive release. Unfortunately, lots of those happening around the world. So uniform is very important, and I just pointed to the bear, the brown bear, as a uniform distribution, because the average size of a brown bear is the same. The territory is going to be about the same order of magnitude. Variations, of course, but it tends to be uniform. Birds are very well known for uniform distribution. Some animals like to stick to one another, but they still need to spread their wings, so they measure the distance between the wing tips, and that's their territory. Just so they can make it 360 or take flight, but they sure like to stick in colonies. Did I say colonies? So here you got a case, you're fourth-year students, so let's go level up. So suddenly I have this aggregate, so I can have a bunch of animals together, but yet within the groups, they have a very uniform distribution. Once you get to know, I'm giving you all the principles. When you get to think about a species, you'd like to think of how are they distributed. Therefore, if I go into call the gannet, this is the seabird, Gulf of St. Lawrence, dives for fish, lives in colonies. They have, they're very aggregate, so that means if you got one, you got 1,000, but within, they're absolutely uniform. And as a biologist, I will say, well, if we want to manage, you got to recognize this is how they distribute themselves. They can't be broken up in pieces. They have to be in aggregates. A colony is a good word if you want to bring it to the exam. Colony, good example of an animal that tracks a few more thousands. And then I could go to prairie dogs, and yeah, they make colonies. Yeah, they don't have a uniform distribution because they can stick to another. They can sleep like this. Prairie dog, another example of aggregate for sure. I find one, it's a problem. I have more than one. Anybody four? Very similar animals that lives in Algeria and the Sahara. that thing, known for just standing on their two legs for the longest time. Meerkat, thank you. Meerkat. Colonies, aggregate, and then within there is no uniform distribution. Gulls will be aggregate. You see one gull, they want to sleep together. Let's talk about this just for 1 minute. Why would they want to be together? Anybody? Yeah,
For protection.
what kind of protection? From predators, how does that work?
Strength of numbers.
No. Strength in numbers, seagull, although there are some birds will do some mobbing and they need more than one. So the odd case, but I'm thinking, let's say, why 100 animals?
Yeah, like, from what I've seen in meerkats, they have like a relay system of like signifying one another.
Yeah, communication system, alert and everything, yeah.
Weird.
When you're surrounded by a bunch of other birds, if a predator comes, we're less likely to be eaten because there's other birds around.
Eaten by the birds? You're saying an Arctic fox comes to a gull colony and it's gonna be eaten by the.
No, I'm saying that if the Arctic fox comes into the bird colony,
Yeah.
if there's, say, 100 birds, you're less likely as an individual to be eaten in that colony. than if you were
Absolutely,
on your own.
absolutely. So keyword, your fourth here, it's called dilution effect. Very common. And that's not strength in numbers, but all those, I like that. The odd case, but I'm thinking or bison or any kind of birds, colonies. Definitely dilution effect is just mathematical. It reduces your chances. You say, oh, I'm your buddy. Or the Canadian joke has it that you stick with someone who runs just a little faster than you. Or there it's to everybody. Dilution effect, but just a little biased. Big small guys like me, I'm always behind in the run. I don't know how I made it this far. All right, enough on this. Of course, long story to talk about one parameter in population, not only abundance, but also how they're distributed. Now, abundance itself should be just a straight number. How many humans on the planet, then you come up with a number. How many bacteria in a country, same thing, number. But the thing is, because of the distribution of animals, you have to look at the area occupied. All right, so the space occupied, I should say. So, for example, I could say, oh, I have people say, I know of 3 minks. 3 minks, everybody, minks, yep. Weasel, water, aquatic. But everybody's gonna say, well, was that over one trap line? And everybody, a trap line in Northern Ontario is 100 square kilometers. Bonus question the exam, because we're talking management. Trap line has 100 square kilometers. 10 by 10. It'll vary. I don't want to get into that. We'll get into specifics of Canadian trapping at some point. But people will ask if 3 minks, that's fine, but is that a lot or is not a lot? Depends on what size you've been looking at. If you were looking at Ontario, it's not a lot. If you're looking at one trap line, suddenly you have a lot of minks, right? So I want to bring you to the idea that most often, abundance is calculated as a density, so it's per unit space. Keep in mind for the exam that there's at least 3 occurring measures of space. If you're a mink, guess what? You're following a creek or a river. Your habitat is linear. Therefore, I have 1 mink per 3 kilometers. 1 mink per 3 kilometers. So therefore, I have a density. I see the density on the line on 1 dimension. Surface is very common. It's per square kilometer, per square meter if you're looking at small wildlife. per kilometer. Otherwise, people will say, we got 20,000 geese in Canada, you got your space again. It's always for the space available. Remember that the same number means low or high depending on the space you're looking at. So pretty important. Surface is very common for many animals, birds, most mammals, as far as I know. The reason why we would work with the volume, it could be, for example, if I have a fish that wants to distribute itself, doesn't care for water temperature. I don't know a specific case, unfortunately. Here we go. Let's talk about, raise your hand for lake trout. Sorry, lake trout. Anybody? Huh? Lake trout? Any fisher anglers around here? Nobody? Zero? Oh, so lake trout. Easy, yeah. So lake trout lives in cold water. In the winter, the whole lake turns 4 degrees. Therefore, the whole lake is available and your trout will be either just under the ice or at the very bottom, everywhere. So that's a case where if you were to measure the amount of lake from that lake, abundance, you'd have to consider volume. Usually we do it per lake because the lake, the depth is known, the shape of the bowl, the area, the volume, everything is the parameter of the lake is known. And it's fairly close and yeah. All right. So long story again, just to mention 3 units, distance, area or surface or volume. Volume, although you saw the question mark on wildlife, I don't have good examples for volume. Again, volume is typical for aquaplankton. We're not talking about. Think of an animal that occupies area. And somebody smart aleck at the example say the red squirrel goes up the tree, so it goes up 40 meters in the tree. So why is it not measuring the volume? Anybody wants to answer that trick question? Why is it that if I count red squirrels and they climb 40 meters in the trees, why am I not considering a volume? I know you all know that intuitively makes no sense to go volume, but why? Simply because they don't pile. If I grow a tree, I'm not adding more red squirrel. It's the same squirrel using the entire volume. If I think of plankton, I increase the volume of water, I will increase the population of plankton. An example for this one. But for your red squirrel, even though it climbs, as the same for moles, they go down in the ground. They're a typical volume. Groundhogs too, but they don't pile up or pile down. All right. Doesn't make more habitat available. So in terms of course, in terms of density, we're looking often at the habitat of the animal. And if I'm looking at a region, I could say Northern Ontario political boundaries as 20,000 years. What do you say? Well, we've got deer everywhere in there. And the answer is no, because it could look like this, and this is taken from somewhere out west, where you got, you know, glaciers, mountain, and glacial lakes like this one. So I didn't put the scale, but obviously I could report my report. I could report the amount of goats, mountain goats, let's say, for the entire region that I'm seeing here, and I'm cheating because there's a freaking lake in the middle. So the lake is not habitat to the mountain. So therefore, I have ecological density is the key word to bring in the exam. Ecological density. That means I consider the area that is habitat to the animal, not just the area. All right. So of course, the distribution, of course, we're interested in counting those animals, and the distribution becomes very important. I think it's A rehash for many of you who've taken their class before, but those are very important principles of population ecology. So if I have a uniform distribution, let's say that you're looking at the swallows on a string, on the telephone line, you'll notice that they all have the pretty good spacing. Same for seagulls and so on. They go on an island and their distribution is very uniform. Therefore, as a biologist, I want to estimate the whole island, but I don't want to walk the entire island all day long. So I will sample. So sampling means they are studying only a part of it. So I have a simulation of a population of 16 individuals here. They're all spread very uniformly. But I'm lazy and I have budget cut. And suddenly I say I have time only to measure the quarter of the island. I'm going to land at one corner and measure. And I count, I don't know, yeah, I have a pointer right here. So bottom right is 4 individuals for a quarter of the island. So I got a density. Good news is the rest is exactly the same, right? So there's no error on the translation to the entire island. So 0 error here. And then we have random, which is terrible. In biology, we prefer to know what the animals are supposed to be doing. For example, if you're a caribou, very odd to find a bunch of lonely caribous. They will be in a herd. So suddenly you're thinking, okay, this is a sick animal. So pretty unusual. And notice that I counted 4 animals. I'm going back for a second here because numbers appear. So for a quadrant, I'm counting 4 individual. I translate to 16. My estimate is 16 for the entire island. But the next one is not so good. I could come up with a predictive of 16 because I got 8, but if I happen to be here, I'm going to say, there's only 8 individuals. You see that? I counted 2 in the quarter of the island, therefore there's 8. Am I off or what? So random is pure hell because suddenly I go over here instead. So at that point, I go over here, I counted 5. In part of the island, therefore, I think there's 20. All population estimates, absolutely basic for any wildlife measure, because the absolute numbers are rarely known for a fact. Animals are mobile, some are highly seasonal. I remember of a trip to Quebec, I visited the natural resources, decided to see if flooding with the great blue heron colonies. And they reported a dramatic decrease in the population because they went only for 2 days over one area. That was their sampling. That's too bad. Instead, we can't see any blue herons. That area is just deserted. Yeah, because you went too late. The animals were gone for down south. So you're limited by the kind of sampling that you're doing. Of course, if you're a scientific, you hope for the best. You say, I want that chopper for that date because I want to catch a calving season or a phenomenon like or running season and so on. So that estimate right here, you realize that this gives me an estimate of 8, and this one gives me 20. I'm just looking at the range. And then the last one is even worse, so aggregate. So here's a situation, anybody wants to speak up on the type of aggregate units we have, animals that live together, what are the terms used so far? There's several. They represent a group. Anybody? Yeah, colonies is good. Anything else? Yeah. Birds is good. Anything else? Families is also valid. some species, yeah. That's flock, absolutely, yeah. All right, so these terms, then this is what's happening, and of course, you can think of one of my favorite animals, the American bison. Just because I was in my 20s and I got hired to serve bison for 400 hours a week, 3 So I would open up the Zoom in the morning at 4:30, they would pop my bison. Yeah. But the beautiful animals, they went from, as I said, from 60 million, maybe 160 million, we're not sure, animals to 300 that were bought and brought to birth. Preserve whatever is left. And well, you're estimating bison, and now in Alberta, Woods Buffalo Park has published 30,000. They have to control the animals because there's a spread of brucellosis. Anybody? Raise your hand quickly. Brucellosis. It's not that everybody it's food specific, but happens in the large population. But very thriving population. But here you're the biologist. Say, okay, in 10 years, let's see how many there are. And you start with your four-wheelers. I don't think I will cover enough ground. I'll come back to the camp because I've been driving for 3 days. I haven't seen this damn bison. So suddenly it's 5 days, still no bison, and suddenly you hit the pocket, right? You go over the cliff and they're all together, right? And you're talking 20,000 animals that are just in one herd. Same for caribou. We all seen movies, areas where the guy is camping quiet in the, in the tundra. Here's a bit of a grumble because caribou's coming. So aggregate situation, very tricky for estimates. If you go into a herd like this, I'm going to point to the 32 here. I just hit a herd, and I want to, and I say this is for a quarter of my territory, and I want to translate to the rest. I'm assuming that the rest, all 3 other quarters are just covered with bison. That's wrong. You know the animals in colonies, so therefore there has to be an end. It's a pocket. Knowing that the distribution will change, that's the take home. The distribution will change the quality of your estimate. So you have to know that these animals, what kind of distribution they have. Sorry for the technical situation, but it's sort of straightforward. Well, it's a simple rule just to get an estimate. And this is, I might have to repeat this at some point. This is very appropriate for lab exercise. 4th year level is too late for this. But basically, if I want to approach, let's say I spotted the bison in the area, I'm in the area, and I know where they are. But I want to know how many. Here's the common strategy. I'm thinking bison, but I'm thinking Canada geese, I'm thinking all kinds of migrating birds. This is a very, very common approach to it. So you sample, you're coming as a biologist, you want to get the final number, an estimate of it. So what you're going to do is mark an initial bunch. So right here, you see the large M says number of marked T0 individuals, meaning very start of my study. I cannot count until I have marked individuals. You know, tell me how you mark a bird, anybody? No?
Like that? Like that?
Like that, yeah, absolutely. Is there any other way? No, I don't think so. Like that works very well. Survival, they do retrieval of those pets, and survival is good if the animals make it through the all right, so I want to estimate these animals. So in migrating birds, they're all tiny little finches and stuff like that. So we use mist nets. So their nets are practically invisible even to the human eye. Once it's spread in the forest with all the shading and everything, we'll just fly right. They're not injured. You handle each animal, you put a bed on the leg and you release it. That's my initial marking. So focus on this equation, and in particular, the 4 items that are listed. So N, M, and the symbols I don't care for, but you want to know what's in the equation, right? So you got your unknown, right? The N on top, abundance estimate. See that? That's the question mark. That's your unknown. You have a bunch of T0 animals. So I'm going to say, oh, I think for the area, I think we're looking at the 200 animals. So how many should I mark? Right? I mean, you got just the historical data that tells you how many animals you're going to see at some point, right? So you got a ballpark figure. Let's say 300 animals, how many should I mark? Answer is if I mark only one, I'm screwed. Well, maybe that lazy. If I mark 300, guess what? I don't need to come again. Mark them all. So I have the definite number. So this is used when you can't get to the entire population. This is called sampling. So you can't go the entire population. Everybody comes from Moose Factory. Matt, you don't come from Moose anymore, no? On James Bay, there's a big island. I mentioned that already. Might as well talk about it. So I can see it in posts. I think they're safe of hogs and so on. So again, at 20,000, there's no ministry that will serve the entire island. Therefore, they will sample, therefore, and they will mark some individuals. And if it's 20,000, they're probably going to mark it 200. So that you can work with the, I don't know exactly what they're called. Maybe somebody's going to help me, but the cannon nests. Anybody heard of those? So those nets are like to fly over a flock of geese. So you spend the whole day marking individuals, and you release them. The capture, marking, release. That's important for example. So I capture, I mark them, I release them. It's not in the they have to be released. They have to be released a long time. I release them for 5 minutes. Not good. I release them for a year. That's better. They have to remix in the population, and then you recapture. That's when your proportion of marked to unmarked. And that's all I want you to remember. The proportion of marked to unmarked in your recaptures will tell you, will help you solve this unknown. As you can see, your unknown is isolated right here. And then we got your simple rule just to so proportion of your, let's see, mark 100 individuals X. Proportional to your recapture. In your recapture next year, you're gonna have, say, 20 marks and 80 unmarked. So 20% mark, therefore I can apply what I have earlier. I have marked 100. Therefore I got an estimate on my population. So I gave you just an example, a very quick example on marking initial 20. Then I recapture 30. No, I recapture 10. And I end up with the estimate of 60. I'm changing topic. So that was very down to the nitty-gritty of something that's very universal. This is the absolute minimum for estimation. There is now, you can imagine, there's all kinds of freeware available. one of them is called Mark, I believe, and you just enter your parameters. I'll give you estimates on your population. I made it a very simple story. When you get hired and paid, hopefully, $600 a year from a team in the field to estimate population. A good chance that you will be repeating this over and over again. You're a good biologist because you know that science cannot be done in a simple flash. Therefore, you will tell your boss, sorry, I have to schedule that health doctor for March, April, and May. I have to come up 3 months and so on. So it's an operation in itself when it comes to just getting the numbers. Migrations might help. You don't have to move. You stay right there. The animals move through. So for salmon, for example, it's been done for a very long time. As long as of course people work the fish, some variable, some certainly, and you know, rivers and so on. But we started using rivers, so we dam the rivers. And suddenly we have to care for the migratory fish. So salmon is one of them that comes from open water and comes into creeks to lay their eggs. So it's fun. So very practical way of counting the fish is standing in a window. You probably, anybody seen those? On your trip somewhere, anywhere, it's called migratory pass. Anybody? No. So they make essentially a water ladder for the salmon. So it just water diverted to the side of a dam that you're using for hydro, for example. And your salmon goes up, it just wants to go upstream. So it'll go into that pass. And often, just to raise money, they will allow people to walk a window where you can see salmon running through. As a biologist, you start on a Monday at 9, you start counting. And that'll give you for the number of days, you know, and then of course you can detect the peak of the migration and general abundance, right? If you can have absolute numbers, at least you want to know if it's decreasing or increasing. So you got historical data, for the future. You can make a projection to see where the salmon in that river is going. Age structure is another parameter that's pretty important, is how many young, how many adults, how many elderly you have in the population. These are human populations, bad example for wildlife really. But we could apply the same principle for any kind of wildlife. Basically, it is expected that you will have a pyramid. And if you look carefully at pyramid, you'll see that it's usually triangular with a large base. Very rarely the other way around. So pyramid is very important, simply because 2 parents will give rise to more than 2 young. Therefore, your juvenile base should be pretty large. Humans is an example of animals. If we decided collectively to restrict ourselves for any kind of reason for the number of young, but if you let it be, and let's say that you breed until the age of say 35, giving birth to a live baby, you will have to produce more than yourself. Therefore, your base, juvenile base, should be pretty large. So that's what's happening in Mexico. On the left, uncontrolled birth rates. People don't believe in contraception and so on, for any kind of reason. The lots of young in the streets in Mexico. Get to the States where parents are more urbanized. I say, you know what, I like my little loft, I like my little condo, we like each other. Why would you have babies? So they call this natality 0 right here, where each elderly at the top of the pyramid is barely replaced by the upcoming youngsters. Try to leave humans out of it, because try to imagine a population that is structured like this in the wild. I'm thinking, for example, elephants. So suddenly, in terms of sociology, could not care less. But in terms of ecology, as far as I'm concerned, if I have any way of monitoring the population and see how it's composed in ages, this is what I hope to see. Large database, all kinds of kamikaze. Raise your hand, kamikaze, anybody? Adam? Kamikaze, you know the term? Yeah, good. All kinds of animal will try their best. The young coyote, the young raccoon, and so on, and then it gets stuck in the garbage somewhere on the top. So, but that's how it's called recruitment. So that's a word you should write down, recruitment. In humans, we don't talk like that. We don't talk about high school, primary school as recruitment, but the fact is, it is a recruit. And of course, Justin Trudeau, that you will elect tonight, will exactly is counting on that, because those are future taxpayers coming in. But that's in Mexico. In the US, not so good. Sweden is very strict as well. So I say, listen, every piece of the land is occupied right now. The rest is inhospitable. Therefore, let's control our population. All right. A very, very simplistic approach to human ecology for sure. But it illustrates the principle. You want a pyramid? Did I say yes? That means that you're looking at the width of base. That's true for, so I'm studying salmon. I want to count the eggs. If I'm counting rabbits, same thing, I want to see young ones. I've worked decades with the trapper, looking at Marvin Fisher every year. If he caught 12 animals, I want to see 3/4 of them being one young one. All right. So age distribution matters. This means that this one is, you understand that this is more solid than this. Understand that? So the replacement is risky here. If you target this area a little bit, suddenly your population is declining. Sex ratios. That's a little more advanced, but it's still very fascinating that animals at different stages of their life, if they live more than 24 hours, but an animal that lives 12 years old will experience different crowds altogether. So, of course, the first line is about primary sex ratio. We all know that as fundamental biology, of course, the DNA is equal in terms of the chances of having a male or female are equal at the and it's called Fisher's principle. No other way around it. Not that interested. What I'm interested in is the managers animals. So secondary sex ratio. Some animals can decide to favor some sex more than the other. So this is true in goats, for example. It's documented that the female, depending on the conditions, food conditions, I'm going to say. In other words, bad habitat versus good habitat, or bad year versus good year. Suddenly, the cancer will produce more males or more females. I believe that it will produce more males than females if the conditions are bad. You don't need to go with specific. This is very species specific, and different species will. Heard of you heard of sex change? Anybody other than humans? Yeah, like any specific case? in my, from, possibly.
Isn't there fish?
Some fish that I know of, there could be other cases, so keep an eye on it. Oh, so you're saying if chickens as well, eh? Okay. I haven't looked into this. I know of fish, so if the sex ratio in the given aquarium is not appropriate, suddenly the females will change their sex, so they'll go to male. All right, so, there are aquarium fishes actually. They're called swordtail. Yeah. That's all right. And then, so already you got a bias at a certain given age. I don't care where it is, but it's called secondary sex ratio. And then you could find another one like end of life. What you see at the bottom right here is something that's been observed in non-goats as well. The males, maybe the reason why the female produces so many males because they're really born to fight and die. So therefore, their life expectancy is lower than female. Now, this is not very surprising. I was very tempted with the images of cafeteria in a retirement home. And count the number of females to males, and you will realize that the males tend have a tendency to be a little less small than females. Therefore, sex ratio could be biased as well. Strategy within so this is, in other words, if you're studying a population, keep track of this, whether it's there's an unexpected pattern for the biology of the species you're looking at. But doesn't mean it's always 50-50. We're almost done, guys. Getting tired of my mask, just like you are. So of course, this is to bring up the exam, very basic, of course, is survival and reproduce. And those are the keywords, really. We call it fitness, just to go short. But that means the biology will study the survival just as good as the reproduction. So your cheetah could not give birth for dying or for not having viable kids, for example. So the two components are essential, especially in management if you're looking at conservation of a species. So, of course, number of births, number of adult number of deaths is always something you keep in mind in order to construct a life table. So very common as well when your animal lives for a long time to see what's happening every year. So it started when people gave their name to a favorite line. So it's a Michael, 8 years old, still around. So you want to know the fate of the animal depending on their age. So X represent, I'm going to call it, in this case, it's a gray squirrel that lives up to 6 years. Everybody sees that. People goes up to 6 years. Pretty old gray squirrel. Really gray at that point. And you get the N for that, I call them cohorts. Cohort is useful because I don't have to talk about months, years, days, or so a cohort is just an age class. And then you get your initial number of 500, and then the L represents survival. I'm gonna maybe show this. You see LX for survival, very technical, but again, it's because it's very standard. When I publish a life table, these are small L for a given cohort X. D for death and Q for death as well. There's a difference between these two. And as far as I know, this one is mortality in a given group. So for example, notice the QX on the right, 0.7, 70%, am I right? 0.7, 70%. And this is the basically, I'm reading into this that the young don't do too well. There's 0 to 1s have 70% mortality rate. And that brings the number from 530 to, I'm sorry, the pointer's gone right here to 159. You see that? That's 70% off. Population just went down in a hurry. Right away, as a manager, you're thinking, okay, well, if my population has to be conserved, I'm gonna promote the cohorts that are fragile, susceptible, vulnerable, threatened. Cheetah is a good example. The young are really targeted by lions. It's the cheetah season. Two kids out of 3 will go to lions every year. So your cheetah is very nervous. Your female, she tries to save one every year. So obviously, if I want to help the cheetah, this is one area I would look into, right? So that's the story about this right here. So, and this is the impact of the death of these guys right here, the 5-6-year-olds. Well, there were only 5 left. So if they go, for the safe life, the impact is minimal on the entire population. You see that? I want to really protect the high numbers right here, but I see that 5, 6 have only 5 animals and they all die, of course, at the end of life. The DX, I'm going to repeat this, the DX represents the impact on the entire, the initial population. 0.01, so that's 1%. All right. 5 over 500 is 1%. Could do the same for insects, for example. Then I'm not dwelling on this, just to show that those tables are common. Again, at the exam, I might show a table like this without interpretation, just to find out if you know LX, DX, and QX. Memorization, pure memorization. I hope this is going to help you read more papers on that topic. Turns it to curves like this. Again, the squirrel lives up to, the graph goes to 7, but the last point is 6 years old. This is QX. And as we said, QX is the mortality. Right here, this one varies with this one we had looked at, sorry, right here, the QX is per cohort, independently of each other, just because in this case, the left graph, obviously you see where the mortality is, right? And, I'm reading this as if I'm a very squirrel and I make this at the age of 1, my mortality chances are decreasing quite a bit. So I'm a 1-year-old, I can fend for myself. I'm a 2-year-old, I fight like crazy, no predators, mortality 40%, and then goes up again because of the parasites get in and so on. Survival, of course, is expected to decline. What we're looking at right here, this just a mathematical modeling approach that's very common now in the literature is called the log survival plot. So because the survival is logged, as you can see on the left, log scale, that brings the mortality to a fairly straight line. What you're looking for, and this is not very dramatic, what you're looking for in the log survival curve is a break in the line, somewhere where it goes flat. Survival is not decreasing like it should. Or if it gets really steep, I see it right here. It's not very dramatic, as I told you. See this right here? Whoop. Right here. See that? This the slope is a little steeper. That represents your mortality in 70%, those young ones that are in the nest helpless. Leads into something like this that everyone out there should know, I think, about the life expectancy, we're expecting LX on the y-axis. I will ask you at the exam to interpret one of these graphs when I do it in formal class. One of the graphs I'll be using. So if I ask you to interpret this graph here, you're going to have to give me the axes first, right? So this is graphing essentially survival LX log over age, no scale. It's a model. I apply to trends or it's really short. I'm gonna finish today with this model and might start again next class with this. You can see, of course, there's three curves. They're very dramatically different from one another. They're called model 1 and 2 and 3. And I can certainly analyze this one right here, initially over age, right? Over age, I'm looking at survival. I hope you can identify that this first portion, whoop, pointer. Right here, this portion right here of the yellow line represents a minimal decrease in survival. That means they're fully protected. How about muskox? Check. These are animals that can survive when they're young. They're fully protected. Muskox is the best example. They got a herd of adults. Number 2 is totally proportional. That means any age class is likely to die on 2. Pretty random as far as I'm concerned. And this one shows a different reproductive strategy. These animals, you can see survival at young ages are really bad. Do you see that? The red curve is dropping. Survival is dropping early. Typical of your salmon, for example. So the female knows about it. Says, well, might as well produce how many eggs in a salmon per female? How many eggs does she lay in given one season? Anybody? About 20,000. So one female. The reason for that is not to hope out. Oh, I'm finishing with this. Who's seen the film Nemo? Very important. Nemo. Right on. Remember the cave? How they went from 20,000 to quite a few, like one. Same idea. So have a nice day. I'm gonna stop right here. Thanks for